Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website, arifpat.me. You can click the appropriate link under the lecture resource column to view it in NB Viewer and run it online in Binder. The other way is to download it from the course GitHub account, Arif PUCID. All the notebooks for this course are housed in this public data science repository. This is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for today's session. Lecture 3.7 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, this is the 7th session on the NumPy arrays. Today we will understand the concept of concatenation, stacking and splitting in NumPy arrays. And before I jump into the code, let me put the stage right by doing a theoretical discussion. And first of all, let's talk about concatenation. The NumPy concatenate method is used to join arrays with respect to a given axis. My dear students, for 1D arrays, the visualization is very simple. So in this figure over here, I have shown the concatenation of 2D arrays, and of course, we can concatenate more than 2 arrays at a time. I am just showing 2. So in this image over the left, the concatenation is being done along axis 0. The axis that moves from top to bottom. The 2 arrays are joined row-wise or vertically. Note that the number of columns of the 2D arrays must match for this successful concatenation. Over here the size is 2 by 1, 2, 3, 4, 5. So over here we have 5 columns. In this array as well we need to have 5 columns. Only then these 2 arrays can be concatenated along axis is equal to 0 or row wise, or we call it vertically as well. Okay, over here in the right image, the concatenation is being done along axis is equal to 1. That is the axis that moves from left to right. The 2 arrays in this case are joined column wise or horizontally. Note that in this case the number of rows of the 2D arrays must match for a successful concatenation. And this is of course the output array that has been concatenated. My dear students, after concatenation we will understand the concept of stacking of NumPy arrays. Stacking is a similar concept to concatenation but is more powerful. In concatenation we can join NumPy arrays only along an existing axis. But in stacking we can join NumPy arrays along an existing axis as well as along a new axis. Well, we can use vstack, hstack and dstack methods for vertical, horizontal and depth stacking respectively. The NumPy stack method is more general of these 3, in which you can specify the axis along which you want to stack the NumPy arrays. Well, over here, let's see this image. Image on the left, this shows a stacking of 2D arrays along axis 0. This is called vertical stacking or joining row-wise. Note that the number of columns of the 2D arrays must match for vertical stacking to be a success. And this is the output array having 4 rows and 2 columns. I hope you are visualizing things with me. And similarly, this image on the right, this shows stacking of these two 2D arrays along axis 1. This is also called horizontal stacking or joining column wise. Note that in this case, the number of rows of the two 2D arrays must match. For this horizontal stacking or stacking along axis is equal to 1 to be a success. And this is the output array having 2 rows and 4 columns. Great. Finally, my dear students, in today's session, we will understand the concept of splitting of NumPy arrays, which is the reverse of concatenation and stacking. In splitting, we simply split one NumPy array into multiple arrays. We can use the NumPy split method to split an array into a list of multiple subarrays of equal sizes. We can use this H-split method to split an array into multiple subarrays horizontally or column wise or along axis is equal to 1. You see this 0, 1, 4, 5, 8, 9, 12, 13, these two columns have been separated and these two columns have been separated. Similarly, we can use a NumPy V-split method to split an array into multiple subarrays vertically or row wise or along axis is equal to 0. So we have a lot to do today. Let's see all this in practice. First of all, concatenation. My dear students, this concatenate method is used to join arrays with respect to given axis. You just mention it, comma separated NumPy arrays, and then you mention the axis. If axis is equal to 0, it will join the arrays row wise as shown over here, and if axis is equal to 1, it will join the arrays column wise as shown over here. Let's see it practically. Over here we have two 1D arrays and I'm calling concatenate on these, and the arrays over here, in case if you want to concatenate two 1D arrays, the arrays can be of any size. Let me import NumPy. Okay. So you see over here I have an array of 5 elements, and over here I have an array of 3 elements, and I can concatenate them along axis 0 over here. If I do not part the axis argument, it also means axis is 0. So axis 0 is going to concatenate it row wise. So 27, 68, 57, 745, and after this second array is concatenated. So for 1D arrays, you need not to worry about the size of the arrays. They can be of any size. And of course, you cannot concatenate 1D arrays along axis is equal to 1 because it does not exist for 1D arrays. I hope concatenation of 1D arrays is clear to you. Okay, as far as the concatenation of 2D arrays is concerned, remember over here now we have two 2D arrays of size 2 by 3 and 3 by 3, and I'm concatenating it along axis is equal to 0. I'm concatenating array 1 and array 2, and remember these two arrays can be concatenated along axis is equal to 0 if and only if these two arrays have the same number of columns, and we do have same number of columns in these two arrays. Let me run it and show it to you. You see we have this is ARR1 2 by 3 matrix, and this is ARR2 3 by 3 matrix. So the number of columns match. So we have easily been able to concatenate it. You see this is ARR1 at the top and this is ARR2 at the bottom. So that is why this is known as vertical concatenation, and that is why it is known as row wise. That rows of ARR1 are placed above rows of ARR2. I hope this makes sense. And if I change the size, let's suppose, let me make it 4. So this will flag an error. Great. Let's move on to the other example. Okay, over here we are concatenating along the axis is equal to 1. This is known as column-wise concatenation or horizontal concatenation. Remember, in this case, these two arrays, ARR and ARR2, which we are concatenating along axis is equal to 1. These two arrays must have the same number of rows, and I have kept the number of rows same in both of them. Let me run it. You see, this is a 2 by 2 array, this is a 2 by 3 array. The number of rows match, therefore they are easily concatenating column wise. This 5838, you see 5838, and then over here we have 427756. So this is known as concatenation along the column or horizontal concatenation. Please visualize, don't get confused from these terms, horizontal and column wise. Okay, let me move ahead and see what next. Now we have the stacking concept. My dear students, concatenating actually joins arrays along an existing axis, either along the 0 axis or along the axis is equal to 1. While stacking can be done in the vertical direction, in the horizontal direction, as well as in depth along the third axis. Okay, along a new axis as well. Well, these are the 3 methods that you can use for this. Other than this NumPy stack method is the most general of these 3, as it has an additional argument, that is the axis, using which you can perform all the tasks that VStack, HStack and DStack can perform using this stack. 2 more variants are column stack and row stack. Column stack is used to stack 1D arrays as columns into 2D arrays, and this row stack is used to stack 1D arrays as rows into 2D arrays. Remember, these two works only for 1D arrays. Okay, let's talk about VStack now. My dear students, VStack method is pass a tuple, and it is going to stack these arrays vertically. So let me straight away jump to this example. I have this ARR1 and this ARR2. They are 2 1D arrays of size 4. So I am vertically stacking these 2 1D arrays. And remember, the output will be a 2D array. So this is the first array and this is the second array, and I have vertically stacked them. ARR2 is placed below ARR1. And remember, the size they must be of the same size, and it is very natural. You cannot have an array of larger size. It will raise an error because they cannot be stacked now, vertically stacked. Great. Let's see another example for 2D arrays. Okay. So VStack for 2D arrays. This is array 1 and this is array 2. Remember, if you want to vertically stack 2D arrays, the number of columns of these 2 arrays must match. Let me run it so that you can visualize it. Okay, so over here, ARR1, this is an array having a size of 2 rows and 3 columns. This is an array having 3 rows and 3 columns. Now, if I want to put this array ARR1 above ARR2 or vice versa, so the number of columns must match. How is it possible that if ARR2 has another column over here, and how can we vertically concatenate or vertically stack these 2 arrays? So remember, that is the reason I have kept the number of columns in both the arrays as 3. So if I change the value to something else, it will flag an error, of course. Great. So I think this V stack is clear. Let's move on to the H stack. My dear students, this H stack method is used to stack horizontally or column wise. Rest of the things are same. Let's straight away go to the example. ARR1 and ARR2, these are the two rows, two 1D arrays that I want to stack now. And note that they can be of different size for horizontal stacking. And remember, the output is always a 1D array as contrast to uh, the VStack method on 1D array. So for H stack, once you horizontally stack these two 1D arrays, the resulting array of course will be a 1D array. And one more thing, their size doesn't matter. You can have any size. Let me make this size 5. So great. Let's see the example for 2D arrays now. My dear students, now this ARR1 is a 2D array of size 2 by 2. This is again a 2D array of size 2 by 3. I am performing a horizontal stack on this. And remember, if I want to horizontally stack these two arrays, the number of rows must match. Let me run it for better visualization. This ARR1 is a 2 by 2 matrix. Yes. And this ARR2 is a 2 by 3 matrix. Now I want to join this ARR1 and this ARR2 horizontally, left and right. I want to keep ARR1 on the left and ARR2 on the right, like this. So the requirement is that the number of rows of the two matrices or two arrays must match, and that is why I have kept the number of rows of both the 2D arrays as 2. If I change it to 3, let's suppose, so it will flag an error. Great. Let's move ahead and talk about stack. My dear students, stack method is used to join NumPy arrays along new axis as well. So this is more powerful. Remember, concatenating joins a sequence along existing axis, while this stacking, the stack method joins sequence along a new axis as well. So let me first perform a stacking of two 1D arrays as usual, a very basic thing. This is an array, this is another array of size 4. I am passing a axis this time. Note that I am passing the two arrays and I am passing the axis. If I pass axis is equal to 0, that means we are stacking these arrays along axis 0. Let's see this. So these are the two arrays. I am stacking them along axis 0. So you see I have got a 2 by 4 array. And if I am stacking them along axis 1, so this 1 and this 6 will be joined, and I will get a 2D array of 4 by 2 size. I hope this makes sense. And one more important thing is that the two arrays must be of same size, and it is very natural. If I want to stack them along axis 0, naturally these 4 rows and these 4 columns of ARR1 and these 4 columns of ARR2, they need to be stacked, so they must be same. And similarly, if I want to join them like this, once again they need to have the same size. If I change the size to, let's suppose 5 over here, an error will be flagged. I hope this makes sense. Great. So let's talk about the 2D arrays now. I'm using the stack method to stack two arrays along axis is equal to 0. So, and remember, once we are stacking along axis is equal to 0, they must have once again the same size or shape. Over here I am stacking it along axis is equal to 1, and over here I am stacking along the last axis. This is -1. This is one way of doing it. since we have just two dimensional array, so these two are the same. Okay, so axis is equal to 0, 791, 538, 451, 945. How they have been joined? So they have been placed above and below. Simple. So in case of axis is equal to 1, this 7, 9, 1, 4, 5, 1. So these are joined in a different way. So after this 791, this 451 has been placed. You see, this 451 has been placed over here, and after this 538 over here, this 945 is placed over here. And in case if you want to stack the two arrays along the last axis, you use the -1 argument. And you see in that case, this 7 over here is joined with this 4 along the 0th row of this. I hope you are visualizing this. Great. So finally, the last thing is the splitting. My dear students, splitting is the reverse operation of joining, and we have different methods for this. Let's start with the split. This split method actually splits an array into multiple sub-arrays of equal sizes. Remember, the important point is equal sizes. So if this 1D array, let's suppose, has 8 elements, and you call split on it with a value of 2, it will divide it into 2 equal halves. And remember, you cannot call it with 3 because there cannot be 3 equal splits of this array. However, if this array has 9 elements, we can always call it with a value of 3. Okay, so the other argument to this split is axis along which we want to split, and the default is 0 if you don't mention 1. Remember, if in this scenario you pass argument 3, so this will raise an error. So the solution is array split method. This array split method does not raise an error. Over here you see we have an a 1D array of 9 elements, and I am passing 4, which is not a factor of 9. So it is starting from the right. It is trying to have 4 equal size partitions, 2 size array, 2 size array, 2 size array, and the remaining 1 element, which is an additional element, is placed in the last array, that is on the left. Remember, this array split starts splitting from the right. Okay, so let's see this in practice. So we have an array and we are splitting it into 4 parts. The size of the array is 20. So this is the array of size 20, and 4 is multiple. 4 is a factor of 20. So great, 1. This is the second array, this is the third array, and this is the fourth array. Let me pass 5 to this. This will also be a success because 5 is a factor of 20. Let me pass 7 to this. This will flag an error. Okay, so remember, you need to keep things like this. So we have now 2 arrays of size 10 and 10. So this is split, and in case of ARR split, array split, we can pass the size which need not to be the factor of the array size. So over here I am passing 3. So over there it raised an error, but over here it is not. So it has divided into 3 parts. So 1, 2, 3, 4, 5, 6, 6, 1, 2, 3, 4, 5, 6, 7, and 7. So 7, 7, 14, and 6 remaining is 20. Great. Okay, my dear students, H split. We have talked about H split before as well. H split method is used to split this array. Let's suppose this is a 4 by 4 array of floating point values starting from 0 to 15. So H split is used to split this array into multiple sub-arrays column wise. Let's suppose I want to divide it from here. So this 0, 1, 4, 5, 8, 9, 12, 13, this will be one split, and this 2, 3, 6, 7, 10, 11, this will be the second split. And remember this size argument, once again, it should be a factor of the number of columns. This over here, if there are 4 columns, so I need to pass a value which is a factor of this 4. So that's why I've passed 2. Okay, so let's see this over here. This is the same exact 2D array that is represented over here in this diagram. And let me split it horizontally. So you see, we have 2 arrays. This is the first array, which is this 0, 1, 4, 5, 8, 9, 12, 13. And this is the second array, which consists of 2, 3, 6, 7, and so on. And similarly, my dear students, vertical split is quite similar. However, it just do that task vertically, that is row wise. So over here I have a 4 by 4 matrix. I am vertically splitting it into 2 parts. So 2. So this 2 should be a factor of the number of rows this time. Let me show it to you over here. So this is exactly the same 2D matrix, having 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns. So I am vertically splitting this array into 2 subarrays. I am using 2. Remember this 2, which is a size argument, this must be a factor of number of rows now. And it is, of course, so this will be a success. So we have got 2 arrays. This is the first array containing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the second array. Okay. Right, my dear students, I think that is enough for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. Hopefully the next session will be the last for NumPy. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.